Hello, everyone. Welcome to our webinar. Sorry for the short delay. I've already started talking. Unfortunately, I didn't notice that I need to hit another button to really start the broadcasting. Now, I hope everybody can hear me from the attendees as well. Welcome to everybody. Welcome to all the attendees to our webinar on the future of auctions in the energy system, where we want to look at auctions beyond renewable electricity. It's an ORS2 webinar that should have taken place in person. Unfortunately, due to the pandemic, we switched to an online format, but we are still happy that so many people are interested in our work and are attending this webinar. So before we dig into the content-related topics, I would like to give you a brief overview on ORS2, our project. So ORS2 is an acronym for Auctions for Renewable Energy Support 2. We are supported through the Horizon 2020 framework, and our project started in November 2018 and is running until April 2022. So sorry for that. I still have the old project end date here. So there are still a couple of more months where you can contact us, discuss with us your questions, discuss with us renewable energy auctions, the design. So we are still here for you. Our project is coordinated by us at Fraunhofer ISI in Germany, and our consortium consists of 11 institutions from 6 EU member states plus the UK. As you can see here, our consortium consists of different partners. So we have universities, research institutions, consultancies, and we all work together to tackle this very interesting and important topic of renewable energy auction design and its impacts. So we have 3 core objectives. The first one is to generate and communicate new insights on the applicability, performance, and effects of specific auction designs. I would summarize it as the research, the actual research on the design of renewable energy auctions. Based on these findings, we want to provide tailor-made policy support for different types of auction applications. So basically get this knowledge to the policymakers and help them design their auctions. And last but not least, we want to facilitate the knowledge exchange between the different stakeholders. And for example, via this kind of webinars and workshops, where we want to get people together to understand and discuss issues in renewable energy auctions. So what are we doing in terms of output? We have several country case studies, 16, I think even more currently. We have the ORS2 auction database. We have different policy briefs. We publish reports on different current topics. We are publishing research papers, stakeholder workshops, and we are collaborating with several countries on actual auction, renewable energy auction implementation. So let's see what we have planned for today. So after this very brief welcome and introduction, we will start with a very brief presentation on the evolution in auctions for renewable electricity. So to sum up by our colleague Bridget Woodman from the University of Exeter, just to give you insights what we think will happen in the renewable electricity sector. But I think most of you are here for the other sectors, hopefully. So we'll continue at 10:20 with auctions for heating and cooling presented by my colleague Jenny Winkler from Fraunhofer ISI. Then we will switch to auctions for hydrogen by my colleague Pia Caddes from Guidehouse. Then I will present you very briefly about the auctions for transport, so in the transport sector. And last but not least, our colleague Bastian Lotz from Guidehouse will present you the approaches for integrated auctions. So you see very different topics, and we will close this webinar with a Q&A session, or rather questions and discussion session, where we want your input, where we want your questions, where we want to discuss with you basically what your opinions on these topics are. So some organizational issues, the workshop will be recorded and published, but without the Q&A session. So feel free to ask whatever you feel like. It won't be published. You will get the link to the recording, so you can share it or rewatch it, and you will get, of course, the presentations of everybody. Just a very specific organizational issue. So if you have any questions or if you want to provide feedback, you have two options. The preferred one is to type your questions in the question box. You should see a small window on your screen or in the application, and just type it in, and my colleague Bridget Woodman will then allocate the question and ask it to the respective person. And during the Q&A session, you have the opportunity to just raise your hand, and we'll give you the opportunity to speak. But the preferred way, I think, is just to type in your question. I think it's easier for us to answer it. And just from the organizational point of view, each presentation will be around 15 minutes. And then you'll have like 5 minutes for to ask questions, very specific questions. If you didn't understand something, please keep your more discussion-related questions for the Q&A session at the end. So, but besides all these issues, I'm really looking forward to a fruitful and lively discussion with you. To give you a little bit of background before we start digging deeper into the topics, you might ask yourself, why should we go beyond electricity? So what's the reason behind this idea? So far, what we can say, auctions have been established as a successful instrument to allocate the support for renewable electricity. So we see a lot of countries using it, and always more and more successfully. You might come up with the idea, okay, we have this instrument of renewable energy auctions or auctions in general. And on the other hand, we have in this case the system transformation that needs to be done to be the pace needs to be increased to achieve our targets, mitigate climate change, etc. And very practically, the competitive determination of support will be continued, will continue to be required by the Commission. Look at the new stated guidelines. All in all, we will still use and see auctions in other fields besides the renewable electricity. And then, of course, it makes totally sense, from at least from my point of view, that we use the experience that we've gained with renewable electricity auctions, because I mentioned before, yeah, they're quite successful now. There were some issues, and there are still ongoing discussions. Otherwise, we wouldn't be here, and we wouldn't have our project, to be honest. And so, use this experience and try to with the lessons learned, we are trying to gain to put this knowledge into the other sectors and other support schemes. So just to give you a heads up, a little bit of a disclaimer. So today is actually the discussion of first ideas for auction opportunities in the other sectors beyond electricity. We are actually experts, especially on renewable electricity auctions, but we are trying to transfer this gained knowledge. And today it's just a first glimpse where we want to discuss first ideas. So we are hoping for your feedback and to continue this work. But yeah, disclaimer, first ideas and a lot of work in progress. And after this webinar, your feedback, we will use it for a summary, a scoping report, which will be the basis for a more in-depth analysis in a potential successor project. So we're currently drafting a proposal for RS3, as you might have imagined, where we want to really put in a lot of effort to understand these auctions and other sectors way more deeply. So feel free to give us any feedback. If we're on the right track, we would welcome that quite a lot. So yeah, thank you very much. And I would like to give the floor to my colleague Bridget Woodman, who is going to tell us a little bit more about the auctions for renewable electricity and what we are going to expect in the future. So Bridget, you should have the control now.
Brilliant. Thanks, Vasily. My my presentation is more about setting a little bit more context for the work that the others are going to present later. Oh, wrong slide. Um, so what I'm going to present is the output from another project within this work package, which looked at the development of, or how electricity auctions might develop in the context of a fully decarbonised electricity system in 2050. And using some of the sort of the key drivers for system development that we're already experiencing today. In other words, the degree to which we may have a more or less decentralized electricity system, and the degree to which the electricity systems in place are what we call flexible. In other words, how they adapt, and how they might be operated, either in a sort of more in a more or less flexible way. We use those two key drivers to generate 4 possible scenarios for electricity system development, which are presented in these quadrants here. So one which is sort of less flexible, less decentralized, another one which is more decentralized but also relatively inflexible. Taking those sorts of those 4 quadrants, we then considered what the implications might be for renewable electricity auctions, who might be doing the auctions, what those auctions might look like, whether in fact auctions were considered necessary, and the design of those auctions was sort of shaped by the conditions in the wider electricity system. That was the output from that was this report that you can see on the right there. But what became very clear from this project was that auctions are changing already, but will continue to change, and they will change to reflect whatever pathway of development we see in the electricity systems over the next few decades. What also became clear, though, was that the nature and the sort of detail of the auctions will also change. So in other words, they're not going to necessarily continue to be run by governments. They may well be run by utilities. We're already seeing businesses conducting their own auctions for renewable electricity. You might also see, in a more decentralized, more flexible system, community groups running their own auctions for local power. It's also very clear that we're not just going to see the continuation of auctions for renewable output. In other words, it's not just going to be for megawatt hours. What is being supported will also likely change depending on developments in the electricity system. So we may end up with offshore hybrid auctions for saving carbon dioxide. We've already seen auctions for seabeds, to lease seabeds for offshore wind projects. The auctions might be for power purchase arrangements. We might also actually, and we're already seeing auctions where there is in effect zero support given for renewable output, and actually the value of the contract is just in the security that it gives to the generator. So there's all sorts of different combinations and different routes of development that renewable electricity auctions might take. What is clear is that things are going to change. And that we may end up, we will end up with a very different sort of set of designs and stakeholders within the sort of electricity auction context. And that's sort of that in a way is by way of sort of framing the following sections. It's not just renewable electricity auctions that are going to go through all these different combinations and evolutions. It is also going to be new technologies and new sectors that may be considered appropriate for auctions in some shape or form. And that's what the following slides and the following presentations will cover. Thanks, Vasily.
Thank you very much, Bridget. I'm just having a very brief look because there is already a question, but I think it's rather one for the discussion. Or if you want to have a look.
I'm just trying to read through it. Yeah, that might be something that we should cover. I agree. It's a great question. I think it's one for everybody rather than just me.
Yeah, certainly. Perfect. Then thank you very much, Bridget, for the presentation. Let's continue with Jenny. Now you should have the control.
Yeah. Okay, hello everyone from my side as well. I will talk to you today about auctions for heating and cooling and whether that might be a promising instrument or not. At the moment, auctions are not very prevalent in the heating and cooling system. There are some examples where auctions are used in some of the European member states. What we want to do at this stage with regards to heating and cooling and auctions is to assess in which areas these auctions might play a role in the future, and then from there we would also go a bit more into the auction details. But what I will present to you today is the thoughts on where auctions could play a role, and I'm very happy, or I would be very happy to receive some feedback from you on whether you believe that using auctions in these sectors would make sense. Shortly on the background, about 50% of the EU energy consumption are used for heating, and of course to a much lower degree also for cooling, but that the cooling demand is of course increasing partly due to the changing climate conditions and the hotter summers that we are seeing more and more. In the heating system, there are very diverse applications and diverse actors. Heating is used in buildings for space and water, and that's about 79% of final energy use in the buildings, about 192.5 million tons of oil equivalent. And in industry, there is space and process heating. About the same amount of energy is used there, and it's 70.6% of final energy use in industry. So heating really plays a very big role in our energy consumption. And in order to decarbonize the heating, we need, or lots of studies, and models and system analysis show that we need an expansion of direct and indirect electrification, mainly using heat pumps. That's of course for the direct part. Then we also need an expansion of renewable energy usage like geothermal, solar thermal, and to a limited degree also biomass energy. Of course, there we have that whole discussion around sustainability of biomass and where to use it because it's a very limited resource. And the third point is also the expansion of district heating and cooling systems will be required to reach that decarbonized heating system. Question for us is now where auctions could play a role, and I will go through the different sectors that are mentioned here separately after that overview slide. So we think that auctions might play a role with regards to infrastructure, so developing new district heating and cooling grids, but also in the expansion and modernization of existing district heating and cooling grids. Potentially, they could also play a role in generation with regards to new renewable plants and heat pumps in existing and new grids, and also new CHP plants. The CHP plants, that's the area where at the moment auctions are most widespread, I think, in the EU. And then we could also imagine combined auctions for infrastructure and generation. That might be new grids with renewables and heat pumps, and possibly also CHP plants or waste heat, and the expansion modernization of existing grids with renewables and heat pumps and or CHP plants and waste heat. That's of course all the auctions that might or could be used with regards to the expansion of district heating and cooling and the increase of renewables and heat pumps in district heating and cooling. I will come to the buildings and industry in the next slides. So with regards to infrastructure, we could imagine that tenders could be used for specific new grids. They are already used as well. They are, and usually they're organized as standard procurement auctions, so that the local government, for example, in the city of Hamburg, they decided they want to have a district heating and cooling grid. So they organized a single unit auction for getting that grid in place. So that's one area where auctions are definitely used, and maybe they could be designed in a way that can contribute more to decarbonization, but we have not looked into the details here yet, as for everything that I present. And also there might be additional potential for multi-unit auctions for new grids combined with investment support. So for example, the government, national government could say we want to have 5 new district heating grids serving at least so and so many inhabitants or buildings, and then they would say and leading to so and so many CO2 savings, and then they could do an auction for getting these grids into place and allocating, for example, investment support for the grids. In this case, the participants could be municipalities, communities, or also grid operators, and pre-qualification criteria could be set in a way to enable deep decarbonization. So that was our idea so far on infrastructure. Now we go to the generation plant. Auctions, as I said, auctions for new CHP plants are already in place. For example, in Germany, Slovenia, and Poland. Usually these are countrywide multi-unit auctions. There are also in some countries auctions for new renewable energy plants and heat pumps in specific grids, for example, in Estonia and Lithuania. And we could see that there might also be a potential for new RES plants and heat pumps as multi-unit auctions. Of course, that requires the precondition that there is third-party access to district heating grids, because otherwise there might not be a sufficient level of competition in these auctions. And the third idea was to have combined auctions for infrastructures and generation. That would mean that we have either new grids with renewables, heat pumps, and or CHP waste heat, or the expansion and modernization of existing grids. Auctions could play a role here. In Germany, we have a very weird auction in that regard already in place, where there's an auction for CHP support, but this is only paid to the CHP plant if the district heating and cooling grid fulfills certain renewable energy requirements. That is, of course, a very complicated design, and it was more introduced due to the fact that the ministry or the department that wanted to introduce that auction only could handle support, or was only responsible for supporting electricity, and therefore they could not pay out direct support for the heating part. Therefore, we see additional potential or alternative potential, as I said, with regards to auctions for investment or operating support for new grids or grid expansion and required renewables and heat pumps, but where the support is directly paid for the heating part or the investment part, and not through the electricity that is fed into the grid by CHP plants. So a short summary of the auctions and the expansion of DHC and increase of renewables. the experience so far is very limited on that. There have been some CHP auctions, also auctions for individual grids and plants. We see, however, a promising potential for auction, but of course, the competition between different sites might be difficult due to the framework conditions, the local framework conditions, for example, the heat density at a certain location and the generation potential also in each individual UC grid. So we think that when designing the auction, one really has to think about the local conditions, especially if it will be a national auction. Then also, as I said before, auctions for individual renewables or heat pumps will require third-party access, which is not in place yet in many European countries, and it's also debated whether that makes sense or not, although the new Renewable Energy Directive is proposing that, at least for bigger grids. And of course, we have not conducted any assessment yet whether auctions might or could perform better here than other instruments to allocate support. We go to the next area, which is okay. Now we have industry here. The new decentral heating appliances. There, the possible role of okay. So I'll talk about industry first. I thought that this will be building first. So in industry, where we could imagine to use auctions would be for new decentral heating appliances. And their auctions could be countrywide, multi-unit auctions, and it might maybe for allocating operational support, because this is necessary for many industries due to the difference in operational costs for some new heating technologies compared to conventional technologies. For example, if electricity prices are higher than gas prices, running a heat pump has very high operational costs for the industry. And possibly and probably a distinction between different technologies and sectors is necessary, because the costs for heating, especially for process heating, vary widely between industries. And then, of course, the question is, if you have to distinguish between different areas of industry, whether there can be sufficient competition in that. And then we go to buildings. There we could imagine that the new decentralized renewable and heat pumps could be supported by auctions in existing and new buildings. Auctions could be used here to allocate investment support for these new appliances. Of course, there we have to keep in mind that homeowners are probably not the right people to participate in an auction. We have some experience here for small PV auctions from France, but it is very complicated and needs to be a very easy process if that is really meant to happen. But still, at least in theory, we could imagine multi-unit auctions for homeowners and real estate companies, for example, in one municipality or even nationwide. And on the other hand, one could also consider single unit auctions, for example, to allocate support for new heating appliances for all houses in a certain district. And their participants in the auctions could be serial renovation companies. And there probably we will have differences between the EU member states, because in some countries you have these blocks of houses where many houses really are of the same, are very similar, of a similar architecture. In other member states where this is usually not the case, because everyone has their individual architect and individual housing arrangements. As I said, there are quite some challenges, like, for example, small actors and also the non-comparability of houses depending on the country and location. So with regards to industry, I think there's no experience so far in using auctions for new heating appliances. From our perspective, it is also we doubt a bit if it's possible to really have an effective and efficient design for such auctions. There's a high variety of technologies, building states and technologies. And for the buildings, small actors are involved. So we really think that both the decentral heating part, both for industry and buildings, we cannot say yet at the moment whether auctions could and should play a big role there, and further research is necessary for assessing whether there really is a potential for implementing auctions in a good way. Okay, this was all from my side on the heating and cooling. As you see, we're still really very much at the start of our research and assessment here, and hope to get some insights from your questions and discussions. And then we will also work on this more in the report and hopefully also in the successor project. Thank you.
Thank you very much, Jenny. Let me check. It seems there are no questions so far. If you have any, please feel free to write them in the question section. Otherwise, as I already mentioned, there's always the possibility to ask your questions or just make some arguments, give us some feedback afterwards in the Q&A session. So still no question, then I would say thank you very much, Jenny. And let's continue with Pia.
Sure. Can you give me the control? Yes.
Now you should be in control.
Let's give that a little check. Yeah, that works. Super. Good morning, everybody. My name is Pia Kels. I'm a consultant at Guidehouse in the public sector team based in Berlin, Germany. And I have written together with the colleagues at Crown the Easy and other colleagues here in Guidehouse a paper on hydrogen auctions. You probably are all aware of the hype that's been created around hydrogen for the past 2 years maybe. And of course, we want to contribute to that ongoing discussion with some high-level ideas on how auctions could be designed for hydrogen. And that kind of already preempts my first slide. Why are we writing this paper? Renewable hydrogen is seen by many as a key solution to actually achieving climate neutrality. The European Commission and many member states have published national hydrogen strategies, which in many parts also include significant funding pledges to support the market ramp up of hydrogen. In the summer of this year, the European Commission has published the Fit for 55 package, which includes a revision of the RED II, and the proposed changes in that revision also really put an emphasis on hydrogen. For example, one of the proposals is to have a sub-target for the use of RFNBOs, so renewable fuels of non-biological origin, which is essentially hydrogen and its derivatives in industry. Keep that point in mind, we'll come back to it. So what's being set out now is a lot of strategies, goals, targets, funding pledges. What we really see is the missing piece right now is the implementation to really get that market ramp up going. And that's where we want to contribute with this paper. We want to provide practical, near-term auction-based policy options to support the market ramp up of hydrogen. If you are already following the discussion on hydrogen support, you will know that there's a lot of instruments that are currently in the discussions. Some of these already include the concept of auctions, some don't. We think that the auctions approach could be highly relevant for the time frame up to 2030. I will explain on the next slide where that concept of 2030 comes from. And then beyond 2030, we expect that the support levels could be reduced as the markets have ramped up. And then a larger emphasis could be placed on really putting quotas on the demand side, to maintain that high level of hydrogen use. Now, a little background on hydrogen. I don't want to be going into this too much, but there's two key challenges that we need to be aware of going forward in this presentation. One, there is currently not really a market for hydrogen, for renewable hydrogen. And that is because the supply of hydrogen, renewable hydrogen, is currently very costly. So at that high cost point, there's no demand, because demand has cheaper alternatives that they can go towards too. Because you have no demand, you also have no supply. So essentially it's that circle that keeps on going that we need to break. And therefore we propose that support instruments in the near term focus both on ramping up supply and demand. So that's one aspect of that challenge. And the second aspect is the infrastructure. I've put here on the slide a map from the European Hydrogen Backbone, which takes a look at what the hydrogen grid could look like in the future. And there's a huge difference here between renewable energies and hydrogen. Renewable energy can feed into the electricity grid, which we know is across the EU, widely spread, very meshed. Still challenges, and the Germans will know that there's massive challenges, but there's the wide network that you can feed in. That's very different for hydrogen. There's currently only very small networks within industry clusters. So the hydrogen infrastructure component really becomes crucial, because you cannot just simply feed into a grid. You need to be very aware of where is your supply, where is your demand, and how do you connect those two components. So based on these challenges, we have figured different designs on how you could respect those challenges, but still implement the idea of auctions. And essentially, we've come up with 4 concrete options that we want to bring forward to the discussion. And each of these are targeted to meet a specific demand or a specific aim, a specific policy need. Option 1 is a demand-side auction for hydrogen. That could be used to really ramp up the demand for hydrogen, for example, in the sector of industry, which, if that RED II revision comes through as proposed, will be very much needed towards 2030. Option 2 is a double-sided auction for hydrogen derivatives. So there's a difference between hydrogen, pure hydrogen, and the derivatives such as ammonia, methanol, that you could derive out of that hydrogen. And that second option here would be a two-sided, a double-sided auction to both ramp up the supply and the demand for derivatives. Option 3 we propose is a supply-side auction. The European hydrogen strategy set out a strategic target of 40 gigawatts to be established. I think we're currently in the context of around 300 megawatts, so we're far from that 40 gigawatt target. And this design option could be used to ramp up the electrolyzer capacity within the EU. The fourth option is a joint auction between hydrogen and renewable energy, so to enable the parallel deployment of both the renewable energy sources you need to generate electricity, as well as the electrolyzers you then need to produce renewable hydrogen. At the bottom of the slide, I've once again emphasized the point that all these options take into account the 2 key challenges I had identified on the slide before. And I also want to add the disclaimer, so to say, that these options were developed for the short term. Once we have developed markets, once you have the infrastructure in place to really enable trade across geographies, these options may need to be adapted. So to keep that in mind, these are short-term proposals. Our focus was to make these proposals as concrete as possible, and to do that we had to take certain assumptions which we want to be transparent about here. So we assume throughout the options that there is enough actors that are interested in participating in the auction, meaning that there is sufficient competition. We also assume that policymakers know about the level of competition so that they can set the auction volumes accordingly. We also assume that the RED II revision will maintain its focus on increasing hydrogen demand in industry hence the focus and some of the options on industry usage. And throughout all options, we assume that the sustainability criteria, which the European Commission will bring forward for renewable hydrogen, will be considered and fulfilled in all options. For the different options, we've also added some considerations that we want to be transparent about here at the beginning. One of which is, if you don't have infrastructure in the near term, you need a different solution for linking your supply and your demand. And one option to do that is to have these two elements, these two parties, establish bilateral offtake agreements before entering into the auction. That way, the auctioneer can be sure that there is a link between those two parties, that they've considered how to transport the hydrogen that they're producing from the electrolyzer to the offtaker. Once again, here we need to make a differentiation between hydrogen and its derivatives. The key difference being that hydrogen is generally needing pipelines to be transported, whereas derivatives can be traded globally more easily via ships. So there's a different dynamic also in terms of the type of actors and the amount of actors you can reach by determining if you're auctioning hydrogen or derivatives. Now, let's head into those different options that I already mentioned. Option one, once again, is the demand side auction with the focus on increasing demand for renewable hydrogen in industry sectors. We need to differentiate here between different industry sectors. So it's not just industry, but it's steel making, it's cement making, it's glass, it's all those different applications. And that is necessary because some of those sectors and applications already use hydrogen today. That's mostly gray hydrogen produced from natural gas. But that means that their production processes already are fitted to use hydrogen. Others currently don't use hydrogen, so to use renewable hydrogen in the future, they need to retrofit those processes. That essentially means that between those two groups, there's very different costs related to the usage of hydrogen. Hence, we propose that we have different auction windows to account for those cost differences. What are the incentives for industry actors to participate in the auction? We think there's plenty. Many industry companies have set up corporate sustainability targets. Renewable hydrogen could be one way to fulfilling them. It could also be a way of greening a certain product to appeal to a certain target group. What's also a good argument, we think, is that by participating in these early auctions, you can ramp up your learning curve on the use of hydrogen in your production processes, which going towards 2050, towards the climate neutrality target, will be needed across the board for those sectors that really need hydrogen to decarbonize. And lastly, with the rising CO2 costs under the EU ETS, switching to renewable hydrogen can save you from having to pay those costs. This option one is focused on pure hydrogen, so not on derivatives. Option two, which I'll present next, is focused on derivatives. So this is in a graph and then in text how we would design that auction. You can see in the graph that there's two elements, one on the left, one on the right. That element on the left is the bilateral offtake agreement I had mentioned earlier. So because there's currently no infrastructure, we propose that the hydrogen supplier and the hydrogen offtaker, so say the ThyssenKrupp, finds the producer for the hydrogen, determines what the cost of production is from that hydrogen producer, assesses its own willingness to pay, And then we know that renewable hydrogen is currently very expensive, so there will be a gap, and that gap can be then filled through support payments determined in the auction. So based on that price difference, the ThyssenKrupp, going back to my example, would participate in the auction. In the auction, we propose that in the different support windows, so for the cement, for the concrete, for the steel, for the glass, that you have specific ceiling prices to account for the cost differences of either having to retrofit your processes or not, because you're already using gray hydrogen at this point in time. So that's essentially what we think could be a feasible design of it. Now, looking at what the auction would be paying out in terms of support, we think that could be either a fixed feed-in premium or a contract for difference, and there is good arguments for both. The advantage of paying out a fixed feed-in premium is that it's relatively simple, and it provides a high cost certainty for the government, which can be an important argument depending on how you finance that support. And it also provides a very high incentive for the bidder to negotiate that offtake agreement with the supplier very well, to keep that gap as minimal as possible. So to make sure that your willingness to pay is really the best thing you can bring forward. The disadvantage of paying a fixed feed-in premium is that it increases the risk of the winner's curse. And that is because the long-term price forecasts for renewable hydrogen are, well, there's wide bandwidth as to where that price could land. So there's a high uncertainty that that the bidders will have to account for. Now, the other option would be to pay a contract for difference. The advantage here is that it really effectively reduces the risk that the bidder has to take on. The disadvantage is you have, from a government's perspective, much lower predictability of what your total support cost may be. In case your support is financed through a levy, so for example in Germany through the EEG, it is less of an issue, but if your support is financed through the state budget, then it could be a problem, because you essentially need to reserve money for the entire duration of your support, which could be easily 20 years. And that could have significant impacts on the actual political feasibility of this kind of support. That concludes the option 1 I wanted to present. The option 2 is the double-sided auction for derivatives. The purpose of this auction would be to provide security to the producers to invest in new electrolyzers, and at the same time to incentivize industry off-takers to switch to green derivatives. I've mentioned the point on the transport before. Hydrogen and derivatives are different in terms of their transportability. The hydrogen can be traded around the world, so we do expect that within this auction you could see participants both from the EU but also from other countries around the world, such as Australia, Chile, Saudi Arabia, countries that are rich in renewable energy resources and can thus produce the hydrogen and the derivatives at a lower cost point. The double-sided auction would essentially function as a platform for matchmaking. Derivatives are already used today, but they're produced using natural gas, so they're essentially gray. And those new supply routes for green derivatives have not established yet. So the purpose here of this auction would be to target those groups on either side, and then to bring them together through that platform to enable the trade going forward. For those of you that are aware of the German discussions around hydrogen auctions, this concept is very comparable to the H2 global concept. Now, what would that actually look like? You see on the figure to the left that you have two sides of the auction and one intermediary in between. So you have the hydrogen producers on the one side, the off-takers on the other, and an intermediary entity in between. The producers have, with those electrolyzers, very high capex and opex, which means that countries who offer investment support, such as the EU member states through the EU Innovation Fund, may be at an advantage participating in this auction. And that, of course, creates incentives for other production countries to provide the best groundworks for their companies going into this auction. And on the other side are the off-takers that communicate their willingness to pay to the intermediary. The intermediary closes contracts with both sides, so there is not a direct connection between the supplier and the off-taker, but it's going through that intermediary. And the price difference between the supply price and the off-take willingness to pay is covered through the intermediary by dedicated funds. While this may look somewhat conclusive of a design, we still have a lot of design questions that remain open and that I've put down here on the slide. Do feel free in the discussion to add your questions to the list of considerations, and we'll discuss. Moving on to option 3, the supply side auction. The supply side auction would be designed with the focus of enabling the achievement of that strategic capacity target of the EU of 40 gigawatts. Again, here we propose, like with the option 1, to have the off-taker and the supplier negotiate a bilateral off-take agreement to take into account that transport dimension. Now, depending on the national political priorities for where that renewable hydrogen should go, the auctioneer could also, within the design of this auction, determine which end-use sector should be taking that hydrogen, and then that could be checked through the bilateral off-take agreement. We do expect that because you have that bilateral off-take agreement, because you have the dialogue before the actual auction, that the electrolyzers would be installed in close geographic proximity to the off-taker, hence reducing also the transport need. Now I want to switch the slide. Vasily, can you help me here?
Yeah, or you want to go back? Yeah.
I want to go to the next slide, but my rights seem to be working. Oh, there we go. Thank you.
Perfect.
Thanks, appreciate it. So the design of this auction can be seen on the left. It's very much like the option 1. So you have the bilateral offtake agreement negotiated first, and then with that price difference in mind, the producer would participate in the auction and would receive support if it is awarded. And now in terms of the support awarded, that could either be investment support or operating aid. We would argue that investment support alone does not ensure the actual production of the plant, and that is because the OPEX shares, so the operational costs of the electrolyzer, are very high. The operational costs are essentially that cost of electricity that you need to account for, and then that becomes your OPEX share. So to really take that into account, you could also pay out operating aid. One caveat we would add here is that if you do that, the electrolyzer has the incentive to produce as much as possible. And what would be useful is if you determine or define certain boundaries within which the system-friendly renewables consumption. Oh, can we go back? Oh, now we're all gone.
Sorry, there might be an issue with the. I'm just checking. It takes a little. I'm just doing one back. No.
One more. We're still on option 3.
Yeah. Sorry, it's a little bit of a technical issue. So.
Okay. All right. Almost done with the slide though. I was just speaking to the point that if you pay out operating support, you need to define certain frameworks within that which that electrolyzer can produce to make sure that it really only produces in a system-friendly manner. So when the share of renewable energy production is high. And lastly, we also recommend to, as with the other options, implement a ceiling price. Moving on to option 4, the joint hydrogen and renewable energy source auction. The focus here would be on enabling the parallel deployment of both the hydrogen and the renewable energy source. One element which is interesting here is that you the way in which you're designing the technical setup of your project really has a big impact on what the final hydrogen cost is. If you have the electrolyzer off-grid, meaning that it only receives renewable energy from that renewable energy source you're building at the same time, that means that it's essentially restricted to the full load hours of that plant. If you're building it on-grid, so both connected to the renewable energy source, but also to the wider electricity grid, it can run independent of the full load hours of your renewable energy source and can produce whenever it's considered plausible. This has strong implications on the operating hours, which also means that it has strong implications on your production costs, because production costs tend to go down as you produce more hours. And what you prefer in terms of the technical design can also be determined through the auction. Auction here is very similar to the supply side auction. One point that we need to add here, which will be decided in the next 2 or 3 weeks, I think, is where the support can go to. The European Commission is currently working on a delegated act on the sustainability criteria for renewable hydrogen. And to my latest knowledge, the renewable energy source feeding into the electrolyzer cannot be supported if that hydrogen is to be recognized as renewable. So that option will have to take that into account. I want to summarize here with a quick review of the 4 options. So we've developed 4 concrete designs which can be used to meet different policy needs. Each of these can be amended by policymakers as needed. So regarding the farm support, the pre-qualification requirements, etc. All these 4 options respect the fact that there's currently no markets and no infrastructure. And hence we also recommend that if you look towards 2030 and beyond, that you reassess those designs and take into account that these are really designed for the short term. And that's it from my side. One organizational remark, I will unfortunately not be available for the discussion later on. So in case you have any discussion points, any comments, please feel free to reach out via email. Back to you, Vasily.
Thank you very much. Pia. Yeah, sorry for the technical issues. There is one question. Oh, okay, it's quite long. I just sent it to you. I don't know if you can already answer it. Otherwise, you might answer it via email. Maybe that's an option.
Yeah,
Looking at the
sounds
time.
good.
So
I
you
actually
might.
can't see the question, so I think that would be the preferred option.
Yeah, I will send it to you, and then you can answer it. Perfect.
Super.
I hope that is. Thank you very much. So looking at the agenda, maybe once there's another one, small one, Pia, if you have the time. Does it seem to be practical to sign a bilateral contract between supply and demand side as a requirement for auction in respect to the effort for such a contract not knowing to succeed in the auction?
Yeah, that's a good question. Essentially, I think any developments that we see at this point in time will already have that kind of negotiation going, because essentially it's that problem. You don't have infrastructure, so you cannot just produce and feed into a grid. You need to know where your off-taker is. So I don't think that that is an additional, I mean, it's an additional ask in the auction, but I don't think it's an additional effort that you're placing on the participants, because they would anyways have to undertake that that dialogue in the beginning.
Okay, thank you very much. If there are no more questions, I would continue with my presentation, the auctions for the support of charging infrastructure. I'm just noticing my internet connection is not that good at the moment, so sorry, I will stop sharing my webcam. Sorry for that. So basically, I want to introduce you to auctions and to the role of auctions in the transport sector. So basically, transport is currently responsible for about 1/4 of all the energy-related greenhouse gas emissions in the EU. And therefore, the Green Deal seeks a 90% reduction in these emissions by 2050. And just to give you a feeling, in 2020, the passenger cars were actually responsible for about 12% of all the greenhouse gas emissions in the EU, and for around 60% of all the transport greenhouse gas emissions. So as you can see, there is really a need and an urge to push the decarbonization efforts into the transport sector as well. And there is a multitude of potential instruments to be used. Let it be CO2 fleet targets for newly sold cars, CO2 fleet targets for trucks, infrastructure for alternative fuel vehicles, quotas, or carbon pricing. So these are instruments for the overall transport sector, but we are going to focus on the infrastructure aspect, since from our point of view, this is the sector or the application where auctions make most sense or could play the most important role. Therefore, in this presentation and later in the report as well, we are going to focus on the infrastructure for private and light-duty plug-in electric vehicles, EVs, and especially on Germany's auctions under the fast charging law. As you know, Germany, quite a big country, most citizens, people in Europe, and kind of a first mover. Nevertheless, there are of course other cases as well. Let it be regional auctions for infrastructure and support schemes in Schleswig-Holstein, a state, a Bundesland in Germany, then in Romania and in Poland. There have already been some kind of support schemes, at least notified at the Commission. So to give you a feeling about electric vehicles in Germany, so far there are all around 500,000 electric vehicles, so proper electric vehicles, and almost another 500,000 plug-in hybrids by October 2021. So actually the purchase of electric vehicles is supported with up to 9,000 euros for battery electric vehicles and around 5,500 euros for hybrids. But the problem is the lack of charging infrastructure, especially in rural areas, and thus the purchase is at the moment, or it seems not that attractive. Similar as Pia mentioned the chicken egg problem in hydrogen, there's a similar issue in the transport sector. So actually the German government aims to support the charging infrastructure. There have already been for smaller solutions. There's already been a support scheme of a budget of around 800 million euros. And there have been 2 rounds. The first one was conducted via first come, first served principle that we, at least in the ORIS consortium, don't like too much, but it has been switched to a competitive procedure. Nevertheless, there is currently another scheme going on, especially for large fast charging infrastructure, which tends to support around 900 locations with up to 4 to 16 HPC, so high power charging points via competitive procedure, or rather auctions. And as you might already understand, this is more or less the ORIS 2 scope. We are looking at the renewable energy auctions from a bigger perspective, large infrastructure projects. So this is basically in the scope of our project. To dive in directly into the auction design, to give you a feeling what has been done. So basically my presentation is more kind of a case study. That's a first analysis, nothing to be generalized yet, but we want to understand the first step. What is going on in Germany? How has the auction been designed? What can be improved? And maybe to derive some lessons learned for future auction rounds in Germany or in other member states of the European Union. So the scope of this auction is the allocation of support for high power charging infrastructure. So each charging point has to have at least 200 kilowatt. A power of 200 kilowatt. So just to give you an idea, the other support scheme that I mentioned, it already supports charging points with starting from 22 kilowatt, power of 22 kilowatt. So this is quite a big difference. From the auction perspective, so all of you who follow our webinars and our reports, you might already know these auction theoretic wording. So we have a sealed bid, static pay-as-bid auction. Nevertheless, in contrast to most renewable energy auctions, it's conducted in 3 rounds. So first, you have a pre-qualification round. So everybody who's interested and thinks to pass the pre-qualification requirements can send in their application. Then the government, or rather an agency, is looking at the applications. Then they decide who goes to the next round. So the next round is the first one where actually numbers are talked. So there is a submission of the preliminary bids by the pre-qualified bidders. And after negotiation phase with each bidder individually, the final bids are submitted and then of course awarded. From the design perspective, we are talking about a site, or rather location-specific auction. There are 23 lots with different sites and locations in 6 regions, as you can see here in the map. And each lot, as I mentioned, is divided into several search areas. They have a radius of 2 kilometers with a given number of HPC charging points that need to be proposed. And as you can see in each region, the different colors, the dotted colors are different, these search areas where the charging points need to be installed after being awarded. So it doesn't mean that, so it can be that lots are in the same region and even in the same municipalities or cities. So getting into the pre-qualification criteria, so the bidder needs to have sufficient experience with charging infrastructure. We still need to have a closer look into that. So if you have any experience with that, or if you want to interchange it, it would be very welcome to get your feedback. If it's a very strict pre-qualification criterion, or it's rather quite easy to pass. And based on that, on this experience and the number of different charging points that they already have in place, there's a ranking during the pre-qualification round. I'll come to that back later. What is interesting, or with what I was stunned a little bit, there is no need for the specific sites yet. So theoretically, anyone can participate, at least in the pre-qualification round, without having any specific locations or specific sites in place or in mind. And a performance bond is needed after being awarded, but not at the beginning, as in many renewable energy auctions. So what struck me as well is the bidder concentration rule. So only 10 bidders per lot are admitted after the first round, the pre-qualification round. So there's actually a ranking based on these on the experience with the charging infrastructure, and only 10 bidders are admitted. So even if there are more, only 10 can submit a bid for a certain region, or for a certain lot, sorry. And in the end, each bidder can only be awarded for 1 lot per region and 3 lots in total. So it's quite limited in terms of lots and locations to be awarded. The award rule it's a multi-criteria auction. This means 65% weighting is for the price and 35% for the quality of the proposal. So interestingly, the price consists of the remuneration for the capex, so the investment cost, which is only, of course, due once, and a certain lump sum as OPEX for quarters. So the bidder says, I need this amount of money for building all the locations and the charging points for the slot, and I need a certain lump sum per quarter just to keep it running. And which is a little bit different to the renewable energy auctions that we know, is that the price should be based on true costs. So the regulator or the auctioneer can actually ask everybody, how did you come to your bid price? What were your calculations actually? And usually in renewable energy auctions, as you all know, bidders can just submit any price that they need without really digging deeper into why they're submitting this price. And so finally, the bid price is one absolute number in euros. So the capex plus the opex lump sum. The quality is a little bit more difficult to quantify, let's say. So first of all, it's the availability of sites. So although it's not really a pre-qualification requirement, it helps actually increasing the chances of being awarded. And then the user-friendly equipment plays a role as well. And last but not least, with a quite minor role, it's the design concept. So how nice does your charging the charging point look like? As I said, the remuneration is, of course, lump sums for capex and opex as awarded in the auctions. A little bit more interestingly is that the government actually caps the tariffs that the award winners and the owners of the charging infrastructure can ask from customers at 44 cents per kilowatt hour. As far as my research goes, it's quite low compared to the owners and the providers currently in the market for fast charging infrastructure. And this tariff includes actually a payment to the government of around 18 cents per kilowatt hour. So this means from these 44 cents that can be asked by customers, around 18 cents need to go to the government, back to the government. And the electricity price, they're calculating with around 17 cents. So more or less the range where the owner and the bidder can actually work with is around 9 cents per kilowatt hour. So the support period is 8 years. But of course, there are some obligations for the bidders. So the bidders need to use renewable electricity, but can be even GOs, guarantees of origin. Storage can be used instead of a grid connection. So this might lead to a ramp up of storage capacities in Germany. And what is striking as well is the a merchant operation of at least 8 years after the end of the support period. So all in all, it has to be there at least 16 years, 8 years under support or with support from the government, and other 8 years on a merchant basis. So you need to know that the auction is still running. Therefore, we only have some first indicative results, and the other ones are based on my thinking or our conceptual thinking and the experience of renewable energy auctions in general. So the first results indicate that there have been around 400 applications for the 23 lots. This means on average around 70 applications per lot. And what has been announced is that there have been double-digit numbers of applications per lot. So quite good competition. Nevertheless, looking at the static efficiency, this means achieving low prices. Apparently there is enough competition, but I would say there is the limitation with regard to the numbers of bidders allowed. And if you remember the 10 bidders per lots, and that and have this bidder concentration rule, this might have decreased the overall competition. Some might not have even participated, or limiting the number to 10 participants might decrease the competition, and the actors and bidders, of course, take this into account when formulating the bids. Then the multi-criteria award procedure, this might harm efficiency. We know that from renewable energy auctions. Simply, of course, if price is not the most or the only award criterion, it might happen that one bidder who has maybe a higher price but a better scoring in the other criteria might get the award instead of the one with the lower price, and that wouldn't be a surprise. Combinatorial bids have not been foreseen, which is actually a pity. Combinatorial bids, I mean with that bidders should be able to say, okay, if I get the lot in this region and the other lot in the other region, I can have synergy effects, and therefore my price would be lower. This would be interesting, especially in this spatial context of the auction. And in general, the lack of transparency, I would say, and simplicity might harm the efficiency, but there's actually a lot of flexibility for bidders, which makes it, of course, a little bit complex. But this might, on the other hand, again, increase the efficiency. And of course, capping the customer tariffs might harm the prices as well. The effectiveness, this means achieving one's goals, the targets. So I would say, since it's oversubscribed, there is some kind of a priori effectiveness achieved. Nevertheless, we don't know the realization rates. Of course, we don't even know who has been awarded. My question a little bit to you as well is if the penalties are high enough. Currently, the penalties are capped at 5% of the overall capex and opex. So at the bid price, maybe too low, maybe too high, I don't know. And the idea is to avoid this real option bidding and or strategic bids. So because one could imagine that participants, bidders go participate in the auction, maybe win the project, but only to avoid that some other market participants get the opportunity to build their charging infrastructure in their territory. The actor diversity, due to the seller concentration rules and several lots designed for small local actors, I think has been achieved, or there has been a focus on that. And what is questionable is the impact on actors outside of the auction. So especially the interaction with existing market actors and HPC locations, which is quite a big issue. And the industry has already much criticized that. And last but not least, the conclusions and questions. So it's a good first step to ramp up infrastructure for electric vehicles. One should consider the impact on other market actors and evaluate that. Actor diversity seems to be quite important and even more important than the static efficiency, so achieving low prices. And all in all, it's quite a complex scheme with a little, somehow a lack of transparency. Let it be the criteria, let it be the negotiation phase, what is going on there. So this could be improved for sure. And just some questions maybe for later for the discussion round. Do you know any other good country examples? Maybe not only auctions for infrastructure, maybe some other part of the transport sector. So do you think auctions will continue to play a role in the transport sector? And furthermore, the complexity versus flexibility, what is the difference there, or how can one solve this trade-off? And last but not least, what do you think about the penalties? Are they high enough with regard to effectiveness and efficiency, of course? Thank you very much. So this time I'm checking myself. There are no questions yet. Maybe some will come later on. To not lose any time, Bastian.
Yes, hi, Vasily.
Perfect. I'll give you the control.
Okay, I'll try it in a moment. So first of all, thank you, Vasily. I had to join a bit later, so I'll just quickly introduce myself. My name is Bastian Lotz. I'm a senior consultant at Guidehouse, based in Berlin, and like Pia, part of the energy public sector team, also part of the OWAS consortium, and we're, among other things, dealing with this topic that I'm going to present, which we call integrated auction approaches. And maybe also, like Vasily, disable my camera. I don't know if that has any issues. So my focus will, my presentation will focus on an additional future area for auctions. And we're currently also writing an OWAS report on this, or a short brief at least, and we call this integrated approaches to auctions. I will provide some more, let's say, first ideas and conceptual aspects, but more focus more time on presenting 3 case studies of such integrated auctions. Let's see if this works now.
Try to click again. You should have the control.
Okay, I try. Somehow doesn't work. I mean, I can see your cursor, but it doesn't continue.
Okay. Maybe I'll just do it for you.
Yeah. That would be. I just clicked. I don't know if that was you or me, but okay. Anyways, we'll try it with the next slide. So to start off, what do we understand as integrated auctions? These are auctions that bring different technological solutions and system services, which may be demand side, supply side, also across sectors, into direct competition for remuneration to provide actually a rather large range of predefined goods or services, some of which I name here, for example, CO2 savings, availability of capacity, reduced load at specific times. So in that sense, similar to renewable energy auctions, providing renewable energy capacities in a cost-efficient way, integrated auctions then can help policymakers discover the most cost-effective or cost-effective options or combination of options that help achieve specific policy goals. And these include, and I mentioned these 3 because these are actually the ones that I will also come back to in the case studies, reducing carbon emissions in the most cost-efficient way possible, reducing or shifting load peaks and avoiding therefore the need for grid expansions, so basically procuring non-wire alternatives, or optimizing the procurement of capacities in the electricity market. Okay, I'm clicking again, but it doesn't work.
One second, it should,
Yeah.
the next slide should pop up soon. Again, sorry for the technical issues. The internet connection worked perfectly, and of course now during the webinar, we have some issues. One possibility would be that you share your screen. I don't know, Bastian, if you have the presentation currently.
Yes.
Vasily, do you want to try giving me control? Because my connection's a bit better.
The problem is that I'm sharing the presentation right now. I'm very sorry about that.
Yeah, okay.
If you can share your screen, Bridget, that's perfectly fine with the presentation.
I'm not quite sure what you mean, but if you, yeah. Oh, look, it's changed.
I'm very, very sorry. Bastian, is this, I think that's the slide you wanted to see.
Yes, that's the next slide.
Then you can continue. Yeah. It might take some time, but we'll do that.
All right. So second point, why can such integrated approaches be an important building block for the energy transition and decarbonization goal? So very broadly here, only achieving net zero emissions by 2050 will of course require, on the one hand, the continued expansion of renewable energy deployment. And this has been done with a very broad adoption worldwide of renewable energy auctions. But it also requires, of course, solutions to integrate these increasing capacities into the system. And on the other hand, we also, of course, need to think about dedicated planning and scale up of other technological solutions beyond renewable energy deployment, for example, demand response and efficiency measures, or flexible capacities, or even CCS. So in other words, governments need to make use of a mix of these technological solutions to really allow for cost-efficient and system-friendly decarbonization and the energy transition. Now I would need to go to the next slide. Do I still have control, or Vasily, are you having control now? Perfect.
I just changed it for you. Just say next slide.
Great. Nice. Okay, so in the next 3 slides, and this is the first of those, I will present, as I have announced, 3 integrated auctions case studies, each with a specific policy goal and the related auction design to kind of give you an idea on the potential diversity of such approaches. The first case here in this slide is the SD++ program in the Netherlands. You probably are aware of this. Which was introduced as of 2020 to extend the then existing SDE Plus program, which focused on electricity and heat from renewable energy sources. The main goal of these new SDE Plus auctions is to achieve CO2 savings in a cost-optimal manner through competition between various greenhouse gas abatement options. And this is done in terms of their achieved CO2 reduction per euro of support. So that's really the main ranking criteria. So far, 2 auctions have taken place under this program, one round in 2020 and one in 2021, each with a budget of 5 billion euros. You might know that even in the previous program, the SD Plus program had a budget approach, so the volume was defined in budget, and the auction volume could only be awarded up to this budget. This is the same here, and this new scheme SD++ is set for 5 years, so with 1 auction every year until 2025 for now. In these auctions, 5 technology categories could participate. So this would be renewable electricity, renewable heat, or more specifically CHP, renewable gas, but also then low carbon heat and low carbon productions, and a variety of technological solutions can participate under each of these categories. They include the kind of conventional, typical renewable energy generation technologies, but also, as I mentioned, CCS, or the production of hydrogen, green hydrogen, and advanced renewable fuels. I've already mentioned this, but the bids are ranked and awarded based on the lowest price. So it's a price-only auction where the subsidy requirement is defined in euro per ton of CO2 emissions avoided. And the support payments in the end are allocated as also as before, just slightly different, of course, because of the CO2 emission reduction approach, as a sliding feed-in premium for each unit of reduced CO2 emission, rather than as before for each unit of renewable energy generated. And the projects receive support for up to 15 years. That depends a bit. There's some variety on the technology. And just to be a bit more specific, since this is a sliding feed-in premium, the support, it's a one-sided sliding premium to be more specific. The required support is determined as the difference between the bid price and an annually determined market reference price. And the CO2 savings for each technology, and that's actually the crucial methodological part of this whole scheme, I would say, are determined through technology-specific CO2 emissions factors that are, as far as I know, statically assumed one time at the beginning of the auction. So they then change over time, and that's actually one of the things that I will mention a bit later. The auction procedure is also divided into 4 one-week phases with increasing levels of ceiling prices. So they start in the first week with a relatively low ceiling price for rather cheaper technologies to participate, and then increase, so to say, over 4 weeks up until the highest ceiling price of 300 euro per ton of CO2. Bit of the outcome of this first auction round in 2020, the most recent one, just happened, I think, in November this year. But in the first auction round in 2020, the largest share, almost 90% of the budget, worth 4.7 billion euros, was awarded to solar PV and CCS. I mentioned this because I think it's really shows also that with these very, very technology neutral approaches, it's very hard, in case that's even a goal, to ensure diversification of technologies. So in this case, yeah, as I mentioned, the largest share went to 2 technologies, so that should be kept in mind here. And something that I have mentioned before regarding the methodological challenges, I think what needs to be mentioned here is that if you compare CO2 reductions, of course, you need to kind of standardize this through, and this is done here through emissions factors per technologies for very diverse measures and technologies, and this is done over the whole support period. So the emission factor is assumed once, doesn't change over time, and of course this is a bit of a challenge because emission factors for technologies can of course change over time. I mean, if you assume just renewable energy generation technologies, the amount of CO2 reduced, of course, depends on the greenhouse gas emissions of the whole power sector, so that can change throughout this 15-year support period significantly, and I think something that creates some challenges. Next slide, please, Vasily. So the second case I would like to present is the Brooklyn Queens Demand Management Program in the US by the utility Con Edison in New York. This case is, I think, relatively widely known for its use of technology-neutral auctions to cover future load peaks and thus defer grid investments, in which both demand-side and supply-side measures could, as well as storage, could participate. And these auctions aimed to basically procure non-bio alternatives to avoid additional investments for distribution grid upgrades. And so in 2016, a technology neutral auction was launched for this purpose for the years delivery years 2017 and 18. The auction, some kind of auction theoretical characteristics here. The auction was organized as in a descending clock format with uniform pricing for 2 time windows in the afternoon, evening from 4 to 8 and from 8 to 12. And for each of these time windows, a specific ceiling price applied, which was also, because, as I mentioned, descending clock format, so it starts with an opening price, and the ceiling price as the highest price also was the auction's opening price in each case. The bid price here was expressed in US dollar per kilowatt in year, and in addition, the successful bidders are remunerated with a call price of $5 per kilowatt hour that was equal across all technologies for the resources activated. And in the end, roughly 23 megawatt of load reduction were procured to cover peak load in 2018, and the bid prices ranged quite significantly between 215 and 988 US dollars per kilowatt a year. More than half of the awarded bidders came from demand-side measures, and this relatively high share of such measures among the successful bid kind of reflects also other experiences that we've seen in other non-wire alternative programs in the US. There has been some criticism on the relatively high prices in this program compared to other programs of the same utility, which some have argued comes from some local market power because certain grid bottlenecks could only be mitigated by relatively few actors, and this is actually really a problem, of course, for auctions, as we know, market power and the use of such market power. There's also been one issue with very high non-realization rates for the battery storage projects, which apparently resulted from a bit of a lack of clarity on the required permits. And since these projects were in the end not realized, the capacities were filled by the remaining demand-side measures next in line, so to say. There were also one learning kind of was that the relatively short lead times made participation for supply side measures rather difficult. So also another argument why demand side measures were so successful. Okay, next slide, please, Hasidi. So the final case is another example from the US. It's the PJM-based residual auction. PJM is the regional transmission organization for Central and Eastern United States. So as part of their capacity market, they have been competitively procuring the required power supply and demand side resources to meet predicted demand 3 years in the future through auctions. And since 2009, also besides the supply side measures, also demand response and efficiency measures could directly compete with supply side generation capacities in these auctions. Here, awarded bidders need to supply electricity, or in case of demand side measures, reduce their load if PJM determines that this is necessary to address load peaks. So it's a capacity market system, capacity mechanism system, and the remuneration is based on the provided capacity or through the energy savings, as well as which is determined by the auction's clearing price. In addition, maybe for the efficiency measures, they need to fulfill certain additional reliability requirements, and the measures need to be evaluated and verified regularly at the time of the bidding, but also for every delivery year, to ensure that the efficiency measures can actually provide us the capacity that they've indicated in the bid. On the outcome, one has to say that the clearing prices have fluctuated quite significantly, and that has been including on a year-by-year basis. For example, one example here is that I've noted is for the delivery of 2012-13, the clearing price stood at $16 and for delivery year 2010-11, so a year before, it stood at $174 so really a huge margin there. Something that has also been noted is that these auctions have consistently procured more capacities than intended or needed, which I think is not so much an auction design issue per se, but just a matter of volumes setting. And also maybe on the demand side resources, they have increased over time to 3.3% of the total procured capacity until recently. And most demand side volumes that have bid into the auctions have actually been successful. However, of course, in absolute terms, relatively few capacities from demand side measures have been awarded. So I've checked only about 9% of the procured volumes for delivery in 2020 came from demand side measures. Next slide. So what are some broad aspects to consider when designing integrated auctions? This is not final, just some first ideas or some general remarks. So as we've heard, integrated auctions typically include resources with very different characteristics, which is one example. Usually energy efficiency measures tend to have shorter implementation periods compared to renewable energy projects, and may also require fewer or even in some cases no permits. And of course, such differences should usually be considered in the auction design to avoid what I would say are unproductive risks for certain bidders, so risks that they basically cannot mitigate through their own measures. And in more concrete terms, this may require, for example, if we look at the auction design, that when integrated auctions are designed, that pre-qualification requirements should be differentiated or at least customized to match these features of different technological solutions. Also realization periods should be technology specific. I've just mentioned that in the previous case study to basically take into account different implementation period that are realistic with each technology's actual implementation or delivery times. You could at least consider technology-specific ceiling prices as is done in this DA++ project to avoid or mitigate at least windfall profits for lower cost technologies. And something very important for looking at efficiency measures and also CO2 reduction, if that's the goal of the auction and you procure this good, you need to have appropriate verification procedures and a methodology in place to ensure that the projects are actually completed and that you have a way of verifying that they're completed. For example, I mean, it's rather easy for renewable energy projects. You have a grid connection and feed in of electricity, but for efficiency measures, of course, you need to. It's a bit more complex because you need a baseline to measure the actual energy savings. So compare the situation without the measure versus with the delivery of the efficiency measure. Final slide, Vasily. So as a conclusion, a brief outlook maybe on when and when not to use integrated auction. So in general, as we have seen, integrated approaches to auctions are relatively novel concept and entail, of course, certain design complexities. In general, policymakers should therefore carefully assess when to use integrated auctions and in which cases it might be more advisable to rely on separate auctions per technological solution. And in particular, I think that integrated auctions tend to be more advisable when the technological solutions and services can actually provide the same good. For example, they can, as I've mentioned, these three policy goals, they can provide in the same quality peak shaving, CO2 savings, or energy system flexibility. Another aspect is if they are more advisable if competing options can actually address the same scale of problem. For example, they can actually counter bottlenecks in the distribution grid. It probably doesn't make sense if that's it's a bit wide here, but the scale of the problem, I called it here, but maybe that it's not so super clear, but I think it probably comes across. And finally, what I mentioned for the SD++ program also, that it's not important that a certain type of technological solution is necessarily awarded. For example, some countries and many countries have renewable energy quotas, and the legislation sets these renewable energy quotas. In that case, for example, probably a supply side specific auction for renewable energy projects would be more effective and safer to actually reach this goal. That would be it for my side.